In this video, I'm going to talk about introduction to the power electronics. The power electronics is nothing but it's a combination of power, electronics, which are electronic devices, and control. So how we control the power by using this electronic devices. Okay, so control system deals with the steady state and dynamic characteristics of closed loop system. A steady state is nothing but, say for example, you're driving on a highway, there is no other traffic and it's a straight road. So in that case, say you're going in the at steady speed, there is no acceleration, or constant acceleration, to say. As long as everything constant, it's a steady state. You're not changing anything. A dynamic is nothing but where you're changing your parameters, like you're changing the direction when you're going the highway, or changing the line going on the highway, or changing your speed. So that system is dynamic system. Closed loop system is nothing but there are two types of control systems. One is open loop, another one is closed loop. Open loop system is there is no connection between the output and input. So basically you're driving your car by closing your eyes. So that means when you closed your eyes, you're driving your car, you're not taking any input, how the road is, whether it is turning or is there any other traffic, you're not taking that input. Okay. So basically what happens, it's an open loop system. So eventually you're going to end up with an accident. If it is a closed loop system where you're taking your output, what is going on when you're driving on your in your car on the road, so it's a closed loop system. You're taking the input, what is there on the road, and you are giving it your brain. You're closing the loop and your brain is saying, okay, apply the brake or change the line or those things. That's a closed loop system. That's the difference between open loop system and closed loop system. So open loop system is here is a system, there is no connection between input and output. This is the open loop. When it comes to the closed loop system, so here is a system and here I have a feedback. Okay, here is my output, here is my input. So based on my feedback, I change my input to the system. Okay, that's a closed loop system and open loop system. Now, the power system deals with static and rotating power equipment for the generation, transmission, and distribution of electrical energy. So power system is basically mostly power generation, power transmission, and power distribution. Nowadays, power energy storage also comes under the power system. Now, the electronics deals with the solid state devices and circuits for the signal processing to meet the desired control objective. That's what the electronic part in the system. So the power electronics may be defined as the application of solid state electronics. So the solid state electronics are nothing but semiconducting material. So we made the diode by using semiconducting material, transistors, MOSFET, IGBTs. Those are all the electronic component. Okay, so solid state electronics for the control and conversion of the electric power. So this is the definition of the power electronics. So one more time, I'm going to read the definition. Power electronics may be defined as the application of solid state electronics, which are semiconducting materials, for the control and conversion of electric power. Now here is a simple example or simple application. So here is the application. I got this slide. Dr. Pawan Kumar Madhuri, he's a friend of mine who graduated with PhD from Wichita State a couple of years ago. Now, if you look at this windmill, here is the windmill. Okay, so the windmill, the wind speed is unknown. It changes time to time. It's a dynamic system basically. So, and that generates AC power, but at the same time it generates at a variable frequency. The frequency is not constant because the speed of that turbine is rotating at different speed. So most of the systems, what they do, they convert that variable frequency AC voltage into DC. So they use AC to DC converter. So they use AC to DC converter, and again that DC again converted into AC by using inverter. So when we say AC to DC, that's called converter, and DC to AC, that's called inverter. Okay, so now there are lots of power electronics components involved there to convert AC to DC and DC to AC again, and at the end the output is going to be AC. So that the turbine is a dynamic system, so there are lots of control needed. Okay, first thing is to rotate the turbine in the direction of the wind, as well as to change variable frequency AC system into a DC power or DC energy. I believe this is a little bit older system, but nowadays whenever you see the windmill outside of Wichita, most of them are around 3 megawatt to 6 megawatt systems. Some of them are 1.5 megawatt. So if you look at a 3 megawatt windmill, so it has inside, okay, inside this turbine, inside this box, basically inside the box they have AC to DC converter and DC to AC converter there itself, and there is a transformer sometimes right here or sometimes at the base, and it will give you a high voltage AC output. Here is another application, electric vehicle. Electric vehicle also, I mean, store energy in the batteries, which is a DC energy. Okay, now that DC energy, but at the same time you're getting energy from the wall when you are charging it. Okay, that is AC energy. So that AC needs to be converted into DC when you are supplying it to the battery. So there is some conversion is there, AC to DC, as well as when it goes to inside, I mean, most of the motors are going to be DC motors. You don't need to convert it back into AC there. But at the same time, sometimes some of the vehicles have this solar roof. So energy is coming from the solar panels, which is a DC power. Now, there is lots of control involved. So in that case, they use the lots of power electronic devices to either conversion and control the energy flow. So those are the simple applications, but there are thousands of millions of applications with the power electronics devices. Now, the power electronics are based primarily on the switching of the power semiconductor devices. So power electronics basically depends upon how we are using the semiconductor devices, which are nothing but the electronic devices, to control the power. The switching speed of the power devices have improved tremendously. So recent years, the switching speed of the power electronic devices is increased tremendously. The history of power electronics begins in 1900 with the introduction of the mercury arc rectifier. But the electronic revolution began in 1948 with the invention of transistor. Before transistor, they invented diode. I do not remember exact year, but it's around the same time, probably 1940s. So diode is the big revolution in electronic industry. After diode, transistor is another big revolution in electronic industry. So the diode and transistors, those are very teeny tiny equipment. So for example, if you look into your cell phone, there are hundreds of thousands of transistors. Okay, so the cell phone is a very small device. In that small device, thousands of millions of hundreds of thousands of transistors are there. So by using that small transistor, we can controlling big amount of power is nothing but the dealing with the power electronics. Okay, now SCR, we're going to use this a lot, called silicon controlled rectifier. Okay, silicon controlled rectifier, and most of the cases we use that synonym for thyristor. Okay, I believe that SCR is the first power electronic device. It can control power. or basically another way of saying it is it can turn on or turn off in a controlled manner. Okay, now SCR was developed in around 1957, late 1957. Now majority of the power electronic devices are made of silicon and can be divided broadly into five categories. So there are five types of power electronic devices. One is power diodes, where I will talk about diodes in a second. And the second one is transistors, BJT, also called bipolar junction transistor. Another one is thyristor. In thyristors, there are SCRs, ZTO, triac, mass controlled thyristors. These are the different types of thyristors. The next one is MOSFET, which is also comes under transistor. Okay, metal oxide semiconductor field effect transistor, and IGBTs, insulated gate bipolar transistors. So there are three categories basically. One is diodes, another one is transistor, another one is thyristor. Because transistors and MOSFETs, IGBTs, all these three comes under the transistors. But transistor itself, there are different categories. One is BJTs, another one is MOSFET, another one is IGBTs. Okay, I will talk about diode in another video. Thank you.